Hello, I'm Al Koritz. I'm Application and Service Manager here at Electron Microscopy Sciences, and today I'd like to show you how to prepare a carbon cord evaporation insert for use, and I'll demonstrate it on the Q150 V+ coating system. The first thing you have to do is separate the upper and lower halves of the top of the chamber by pulling out the silver knob here in the front. It releases the latch, and then you raise the top half. Then you can turn these knobs, which lock the insert into the chamber, and just gently lift it up and move it over to the bench top so you can work on it in a convenient manner. Okay, so we have the carbon cord or carbon thread insert here on the bench top. It has a used set of fibers or cords installed already from a previous evaporation. So I'm just going to take the hex driver and loosen the hex screws here on the back side, if I can get the correct one. There we go. I had the correct one to begin with. So you loosen these several turns. Those screws hold down these spring-loaded paddles. The paddles were originally used as a quick method of just sliding your carbon cord underneath the paddles, but we found that it really needs a robust contact, so you need to get your hex driver out and tighten them down. Periodically you will need to run some emery paper in between the contacts. I use an actual emery board that you would use on your fingernails with two sides of abrasive, and you just drop it into the slot and you just move it back and forth. Then you blow any debris that you free up with a can of canned gas, and then you're good to go. But for now, since this has been recently cleaned, we'll just continue. So here we have a bulk length of carbon cord. There is also carbon thread, and which is a thinner variety. For our application today, controlled pulse cord, which the computer on the Q150 V+ will actually control the evaporation process and do it in a reproducible manner. We'll be using this heavy carbon cord. So the first thing you do is you slide the loose end down between the paddles, and then depending on whether you're left-handed or right-handed, the side with the loose end, you would tighten the hex screw down till it's snug. No need to really over tighten it. You pull the other side tight, and you tighten down that screw till it's snug. Then all I do is, with a pair of sharp scissors, I snip the bundle of carbon cord free, and then I'll snip the other end just to make it all nice and tidy. You can't use a razor blade. Those carbon fibers are pretty impervious to razor blades. The shearing action of the scissors is actually the way to go. So now that it's loaded, we will use a lint-free cloth and we'll make sure that the sealing surface on the insert is free of all dust, dirt, and debris. And now we'll go back to the machine and install this. Okay, we're back over here at the instrument. And the first thing I'm going to do is there's an O-ring that's in here, and it's really sort of an overlooked O-ring. It's under the insert. You need to make sure that that's free of dust and dirt, as you did with the sealing surface on the insert. Quite commonly, if people have trouble pumping the system, a lot of times they've forgotten that there's an O-ring under there because they don't remove the insert from the chamber. Some people will actually service the system with the insert installed, and you just would gently move the shutter aside, loosen the set screws, install the thread, tighten the set screws, cut, and then you're back in business. I prefer to do it on the bench top rather than have carbon fibers fall all over the place. Also, there's better lighting and it's much more comfortable than standing over the machine, depending on the height of the machine and whether there's cabinets over top. It's just much more convenient to do that. So the next thing you would check and make sure that the sealing surfaces on the whole upper arm is clean and free of dust and dirt, as well as the sealing surface here, as well as the sealing surface here and here at the top and the bottom of the chamber. Now, just for illustration purposes, I'll just put a cover slip on the stage, and I'll put an SEM stub on the middle of the cover slip for contrast. We're using the tall bell jar with this process today. Using the tall bell jar allows us to take advantage of the film thickness monitor, which is heat sensitive. We put the evaporation source much further away from the FTM, and it has time to recover and accurately read. Evaporation is a very heat generating process. It's a thermal evaporation, whereas sputtering is a cold process, and we can move to the lower half height chamber where the source is much closer to the film thickness monitor as well as your specimens, but that's a different lesson, different day. So now that it's all prepared, our sample's in there, we can close the lid, and now we can talk about the display on the Q150V Plus and your options for carbon cord evaporation. I shut the room lights off so there was no reflection on the display, so everybody could see it clearly. This is the home screen for the Q150 Plus series. There's a number of areas you can go. However, we're mostly interested in the recipes, so we'll just touch that. You'll see a list of different recipes: vent chamber, run stage, pump down, vacuum shutdown, pulse cord evaporation, control pulse cord. Those are the two that we're going to talk about. If you hit the down arrow, you'll see a number of different parameters. Some are grayed out, some are dark. The dark ones, depending on your user level, you'll be able to change. The grayed out ones, you need a higher password in order to operate it. So pulse cord evaporation, the system will pump down to a desired pressure range over a certain amount of time, which you can specify, and then it degasses the cord, so any contaminants are driven off. There's a short recovery time, and then after the vacuum recovers, the computer gives full current to the cord, evaporating it all at once. The one we're going to talk about today is controlled pulse cord, which is quite similar. However, the computer takes control of the system and aims to terminate the process at a given thickness. It works really well between like 2 nanometers and 18 nanometers. Sometimes you can get 20 out of a piece of cord. The way you would change your termination thickness is it gives you a minimum and max on the display, and you just simply type in the number of the thickness in nanometers you wish, hit confirm. Although you can change these other options that are in black here, I really don't recommend that. These are pretty well set at the factory and thought out, so we'll just not bother with them. So in order to initiate the process, you simply just hit controlled pulse cord and the green arrow, and the system will start that process. So that click click is the shutter opening and closing, so the system knows where the shutter is. And you can see the pressure starting to come down as the roughing pump roughs the chamber. The turbo pump is starting to come up to speed. And now we're waiting for the vacuum to get to the range in which we would evaporate. Okay, a few minutes have elapsed. The system has pumped down to 6 times 10 to the minus 6 millibar. One important thing to remember is the quality of your carbon deposition is directly related to the vacuum level you're able to achieve. And in a lot of cases, it depends on how long you want to wait and how urgently you need to coat that sample and get it out of the system. With the Q150V Plus, it's able to achieve those lower pressures in less time due to a highly efficient vacuum system. So we're just going to press continue on the menu here, and at that point the system you'll see a glow in the chamber, and that's part of the reason why I left the light off. The carbon cord will glow to outgas. Then the outgas duration is a set time at a set current. Once it recovers, then the system will start pulsing the carbon cord in increasing amounts of current till the desired deposition is achieved. So I'll press continue. System is outgassing, the pressure is going up because we're liberating water vapor and whatever else has been absorbed by that carbon cord. Now it's in the recovery process, and the pressure is going back down in the 10 to the minus 6 range. And the next thing you will see, the system will start to pulse the cord, and that signals the starting of the deposition process. The amount will be recorded by the film thickness monitor, and the thickness deposited will start incrementing towards that final thickness that you preset in the software. It's almost done with outgas recovery. So there's our first evaporative process. It will continue pulsing until the cumulative deposition is what we achieved. It ramps the current up very slowly so the cord does not burn through all at once like in pulsed cord evaporation. This is controlled pulse cord. Okay, the system recorded 10.76 nanometers total evaporation. You can see the green light flashing, which means the process was completed successfully. Venting, blue means that it's in the process of venting. They added this illumination system, so from across the room you could tell the status of the instrument. So it's allowing the turbo pump to spin down before slowly venting the system. You can hear it opening and closing the vent valve as the system slowly vents. This is very important if you're carbon coating grids. You don't want them blown all over the chamber after you spent all the time preparing them and getting them in the system. Okay, the chamber is vented. Let me turn on the light. Since the chamber is vented, I can terminate the venting process to save nitrogen gas. We vent our systems with ultra high purity nitrogen. And I can show you the results right here. 10 nanometers of carbon on a cover slip. And we can do that very reproducibly. This is a previous 10 nanometer, and you can see how close that is. Okay, so that's how you use controlled pulsed cord in the Q150 V+ system. Controlled pulse cord is also available for older systems, the Q150T and the Q150R systems. The process is exactly the same, it's just the interface is different. So that's the end of this tutorial.